Okay, on lesson 2, we're going to look at the properties of dilations, and we're first going to look at dilations map lines to lines. And let's just remember that the word map just means moves. So when we're mapping something, we're just going to move a line and it's going to become a line. Okay? And dilations, we talked about those in lesson 1. We're just going to expand on them a little bit more. And you're going to need a compass, so go ahead and grab your compass out of there. And we're going to work through this. So we are looking at this example here. We have a center O. We have line L, and it has points P and Q. Okay? So what we're first going to do is we're going to draw rays from the center through each point. Okay? So just take your compass. And use your straight edge to draw a line from the center through each point. It's probably longer. There we go. Okay, and what we're going to do is we're going to just use the definition of a dilation to work through this. So what we have to know first is the distance from O to P and O to Q. So the distance from O to P and the distance from O to Q. I'm going to measure that first. So center of the dot to center of the dot. 2.3. You could go 2.4. When you're measuring, you want to be as accurate as possible, so 1/10 off is okay. 3 point, I'm going to go 3.6. Okay, and then we're just going to use a scale factor of 2. So all that means is we're going to take this length right here and multiply it by 2. And the same thing here, our scale factor of 2. So the length from O to Q prime and the length from O to P prime would be 4.6 centimeters. And the length here would be 7.2 centimeters. So what I'm going to do is I'm going to take my compass and I'm going to move it to 4.6. And I'm going to put the center here on O. Just like that, right in the middle. I'm going to hold it with my finger. I'm going to take, I'll just mark with this, my pencil, and I'm just going to make a mark right there. Okay, that point right there is what we're going to say is P prime. And I'm going to move now my compass to 7.2. I'm going to do the same thing on the other line. I'll line it up. I'm going to hold it. I'm going to make a mark here on my line. Okay, and that would be Q prime. And then we just take a straight edge. I keep wanting to turn the paper. And draw a line through the points. So now we have taken this line and dilated it and got this line. So when we do a dilation, if it was a line to begin with, we should have a line to end with. Now if we did this again with the scale factor of 3, oh, you can't see that. Okay, the distance from O to P prime prime would be 6.9 centimeters. And if we did the same thing over here, distance from O to P prime prime would be 8. 1, 10.8 centimeters. Okay, so we just adjust to 6.9, line it up, onto it, make a mark on our line. That would be P prime prime. Ooh. And over to 10.8. Make a mark on our line. This would be Q prime prime. Okay, and then we just use a straight edge to connect them. So this is what it looks like with a scale factor of 2, and this is what it looks like with a scale factor of 3. We're just moving further away from the center. Okay. Alright, so let's look at this example. So on this example, we're doing the same thing, except for now our center is on our line. So here we're going to use a scale factor of we can do 2. So again, we're going to measure the distance from O to P and from O to Q. Okay. So we measure, that looks like 1.6 centimeters. .4 centimeters. Okay, and so if I multiply this by 2, 3.2 centimeters, and O to Q prime would be 4.8 centimeters. Okay. So I'm going to move this to 3.2 right there. Line it up with my center. Hold my point. Here's my 3.2. Make my mark. I come over here and do the same thing with 4.8. Make my mark. This would be P prime. This would be Q prime. Now, I'm going to also show you what this would look like if we use a scale factor of less than 1. So if we use a scale factor of 1/2, okay, the distance from O to P prime prime would be half of 1.6, which would be 0.8 centimeters. And the distance from O to Q prime prime would be half of 2.4, which would be 1.2 centimeters. So, this is a little tricky because our compass doesn't do that. So instead of using our compass to do that, I'm just going to line it up. Our compass won't go below, looks like 1.3. So I'm just going to line it up in the center. I'm just going to make a mark here at 0.8, P prime prime. And I'm going to do the same thing at Q. So we don't necessarily have to use the compass to do that, but we can. Q prime prime. Alright, so when the scale factor is greater than 1, okay, the points move away. When the scale factor is less than 1, the points move toward the center. Okay? Greater than 1, the points move away from the center. Less than 1, the points move toward the center. Okay, so here we're going to dilate the triangle with a scale factor of 3. Okay, so what's going to happen here is that everything is going to get further away from our center. Okay, so what we're going to do is we're going to draw lines, and I'm going to use the ruler this time just because it's longer, and we're going to need something with a little bit longer. So the first thing you're going to want to do is to draw a line from the center to each point. Now, when I do this, I go ahead and measure it, so I don't have to worry about it later. Go back and measure it again, and I'm going to say that is 3.3, yeah. .8 and 2.8. Okay, so then I'm going to take each of these numbers and multiply them by the scale factor. So 3.3 times 3 would be 9.9. So I just line up my ruler with this, and on the line at 9.9, I make a point, and I label it C prime. The original is C, this one is C prime. Okay, same thing over here with B, 3.8 times 3, 4.4, 11.4. And then the same thing here, 7.4, 2.8 times 3, 7.4, A prime, and then I connect my points to make another triangle. So, okay, I dilated this triangle and made this one. Now, we need to know that these are similar figures. We've taken the shape and used the proportion, the scale factor of 3 to enlarge it, okay, to magnify it. So now we're going to answer some of the questions. Note that triangle ABC is made up of segments AB, BC, and CA. Were the dilated images of these segments still segments? Yes. Okay, we started with segments, we end with segments. So when dilated, segments are still segments. Okay, I'm just going to move this up and pull this other paper out. Okay, B, measure the lengths of segment AB and A prime, B prime. What do you notice? Think about the definition of a dilation. Okay, so segment AB, um, 1.8. Segment A prime, B prime. Did I measure? Right. Yep. Maybe I didn't do some calculation. Oh, so this, I messed this up. This should have been 8.4. Sorry, guys. I'm like, something is not adding up right. I didn't do my math right. I'm sorry. Okay, so we're using this point. So if we measure this, we get 5.4. Oh, so much better. So 5.4 centimeters. And what you see here is if you take 1.8 times 3, you get the 5.4. Okay, so segment A prime, B prime is 3 times the length of segment AB. So that proves that the distance from A prime to B prime is the scale factor times the distance from AB, distance from A to B. Okay. So if we do the same thing, we would measure the distance from B to C, which is 1.2, and the distance from C to B prime is 3 times the length. Apparently I can't measure. That's 1.7. This is 5.1. 2.7 or 8, and then 2.7 times 3 would give us this 8.1. Okay, right here. So this means that dilations affect segments in the same way they affect points. The lengths of segments are dilated according to the scale factor. Okay. D says, what do you notice about measure of angle ABC and the measure of angle A prime, B prime, C prime? So you'd use your protractor and do a little bit of measuring. Line it up. Okay, the center with the point here, and I'm going to count all the way over to here, and it just barely misses. 100 105 degrees. So angle ABC and angle A prime, B prime, C prime is 105 degrees. I think I'm going to have to extend the lines. So I can measure this one here. Again, when I line it up, I get about 105 degrees. So I noticed that the angles were equal in measure. Okay, so if we do the same for the other angles, okay, if we look at this angle up here, if we look at this angle up here, I see that it's the same angle measure as this one. And if I look at the angle down here, it's the same as this one. Okay, so on E, okay, I would say that dilations map angles to angles, and they preserve angle measures. Okay, so we went through and we saw a couple different things. Here, dilations map lines to lines. That's what we also saw here. And they map segments to segments. So and then when we're looking at this, when our scale factor is greater than 1, the points move away from the center. When it is less than 1, the points move toward the center. On this example, dilations map segments to segments according to the scale factor. Dilations map angles to angles. And they also preserve the angle measures. So they're the same angle measurements when we dilate them.